illustration of Fajans rule. Fajans introduced the term ionic potential phi to express the polarizing power of a cation as phi equal to charge of the cation by radius of the cation. Thus, with increase in the cationic charge and decrease in the cationic radius, that is, increase in the ionic potential value of a cation, its polarizing power and hence degree of covalent character of a compound increases. Again, ionic compounds are high melting while covalent compounds low melting. Hence, increase in the melting point of an ionic compound indicates increase in the ionic character and decrease in the covalent character. Now we consider charge on the cation. Let us consider, for example, SnCl2 and SnCl4, both of which contain same anion Cl minus. But here the cation is Sn2 plus and here Sn4 plus. It contains 2 plus positive charge and it contains 4 plus positive charge. Sn4 plus is more polarizing than Sn2 plus. Since phi value of Sn4 plus greater than phi value of Sn4 plus greater than Sn2 plus. Consequently, SnCl4 is more covalent than SnCl2. Hence, SnCl2 is high melting than SnCl4. Now we consider second factor, radius of cation. According to Fajans rule, with decrease in cationic radius, phi value increases. Consequently, covalency of ionic compound increases and its melting point decreases. Order of radii of group 2A metal cation is beryllium 2 plus less than magnesium 2 plus less than calcium 2 plus less than strontium 2 plus less than barium 2 plus. Hence, the order of polarizing power of the cation will be beryllium 2 plus greater than magnesium 2 plus greater than calcium 2 plus greater than strontium 2 plus greater than barium 2 plus. That is, the order of the polarizing power will be reversed. Thus, the degree of covalency increases with the polarizing power of the cation and the order of melting point of the chlorides will be beryllium chloride less than magnesium chloride less than calcium chloride less than strontium chloride less than barium chloride. Radius of anion. Now we consider radius of anion. According to Fajans rule, the polarizability and hence covalency increases with increase in the cationic size. The order of radii of halide ions is F minus less than Cl minus less than Br minus less than I minus. Hence, the order of polarizability of these anions will be F minus less than Cl minus less than Br minus less than I. That is, the order of polarizability of the anion will be same as that of order of radii. Consequently, the order of covalency of sodium halide is NaF less than NaCl less than NaBr less than NaI. Hence, the order of melting point will be NaF sodium fluoride greater than sodium chloride greater than sodium bromide greater than sodium iodide. Finally, we consider the electron configuration of cation. According to Fajans rule, cation with pseudo inert gas configuration will exert greater polarizing power than cation with inert gas electron configuration, that is NH2P6 configuration. Consequently, the compounds containing H2P6 D10 ion will have greater degree of covalency and lower melting point than compounds with H2P6 ions. That is, compounds with H2P6 ions have lower degree of covalency and higher melting point. For example, NaCl and CuCl, both of which contain the same anion chlorine Cl minus. Here the cation is Na plus. In NaCl cation is Na plus and in CuCl cation is Cu plus. The electron configuration of Na plus is 2H2P6, that is inert gas electron configuration, and electron configuration of Cu plus is H2P6D10, that is pseudo inert gas electron configuration. That is why NaCl is high melting than CuCl.